Welcome to aminacademy.com. In physics, let us discuss about alternating current, that is AC current. What is alternating current? Alternating current, AC, is a type of electrical current in which the direction of the flow of electrons switches back and forth at regular intervals or cycles. Current flowing in power lines and normal household electricity that comes from a wall outlet is alternating current. This is a alternating current, peak happening alternatively upper and lower. What is EMF generated by a rotating coil? In a magnetic field has a graph similar to shown here. It is called an AC voltage because there is a reversal of polarity, that is the voltage changes sign. AC voltages need not be sinusoidal. If the coil rotates with a frequency of F revolutions per second, then the EMF of frequency of F in hertz, that is cycles per second. The instantaneous voltage V is generated has the form of V equal V0 sine 2 pi ft and time period T equal 1 over F, where F is the frequency and final voltage V and V0 is initial voltage. That is V0 is the amplitude maximum value of the voltage in volts, the omega equal to 2 pi F. Now the electromotive force EMF generated by rotating a coil is in a magnetic field is a function of time and is given by the equation EMF equal to 2BLV sine omega t. In this equation, A is the area of the coil, N is the number of turns, omega is the angular velocity, and B is the magnetic field. The peak EMF of a generator is given by the equation EMF equal to NAB omega. Here are some other things to know about EMF generated by the rotating coil. You know that Faraday's law of induction, the relationship between the EMF induced by a change in magnetic flux and the number of turns in a coil is described by Faraday's law of induction. The equation of this relation is EMF equal to N delta psi dt. Next, voltage oscillation. The voltage oscillates as the flux goes from positive to negative. The peak voltage is 2 PF NAB. Note these points. Next, factors that increase the voltage. The voltage increases with a higher rotation of frequency, bigger loops, more loops, and a stronger magnetic field. These are the factors to increase the voltage produced. Energy generated or power loss in AC current. The formula for calculating power in an alternating current AC circuit is P equal to IV, is from Ohm's law. Then where P is the power, I is the current, and V is voltage. And different forms of power formula and as well Ohm's law, we are getting these formulas. This is collection of our formulas together. Next one, some meters for using circuit read the effective or root mean square RMS value of the current and voltage. These voltages are always positive and are related to the amplitude of the instantaneous sinusoidal value through that normally V equal V RMS root mean square voltage, which is equal V0 over root 2 and approximately equal 0.707 V0. Similarly, I voltage equal IRMS equal I0 over root 2, which is equal 0.707 I0. Here, now forms of Ohm's law. Here, thermal energy generated. Thermal energy generated equal power equal I squared R, where R is the resistance of the circuit. Now, forms of Ohm's law. Suppose that a sinusoidal current or frequency F with RMS I, the flow through a pure resistor R or pure inductor L or pure capacitor C. Then an AC voltmeter placed across the element in question will read the RMS voltages. For pure resistor, V equal IR, the formula. Pure inductor, that V equal I XL, inductive resistance XL, where XL equal 2 pi F L. F L is the inductance. Then pure capacitor, V equal I XC, capacitor resistance, where XC X equal 1 over 2 pi FC. It is called capacitive resistance. This XC is the capacitive resistance, where C is the farad. Next, phase in AC voltage. What is phase in AC voltage? When an AC voltage is applied to a pure resistance, the voltage across the resistance and the current through it attains their maximum value at the same instant and their zero values at the same instant. The voltage and current are said to be in phase. That means at the same time voltage is maximum as well as current is maximum. When an AC voltage is applied to a pure inductance, the voltage across the inductance reaches its maximum value 1/4 cycle ahead of the current. That is, when the current is zero, the back EMF of the inductance causes the current through the inductance to lag behind the voltage by 1/4 cycle, that is for 90 degree, and to are 90 degree out of phase. When an AC voltage is applied to a pure capacitor, the voltage across it lags 90 degree behind the current flowing through it. Current must flow before the voltage across and charge on the capacitor can build up. In more complicated situations involving combination of R and C, the voltage and current are usually but not always out of phase. The angle by which the voltage lags or leads the current is called the phase angle. Yeah. First, we'll include phase shift. When two or more waveforms are out of step with each other, meaning their peaks and 0 points do not match up the same time, the phase shift is measured in degrees relative to two things. like voltage A being 45 degrees out of the phase with the voltage B. Next, phase voltage. What is phase voltage? The voltage measured between any line and neutral in three-phase electric power system. For example, 208 120 volts service has a line voltage of 208 volts and a phase voltage is 120 volts. Number of phases. In household AC power, a single phase waveform is used, which is a sine wave that repeats its cycle 50 or 60 times per second. A generator can be split into the three phases to create an almost constant stream of power, which is better for long distances transmission. Next one, what is impedance? The impedance denoted by Z is an expression of the opposition that an electronic component, circuit or system offers to alternating or direct circuit current. Impedance is a vector, that is two-dimensional quantity consisting of two impedant scalar one-dimensional phenomena, resistance and reactance. These are two phenomena, resistance and reactance have the impedance. Here impedance formula is Z equal to impedance square root of R square plus XL minus XC whole square, where XL is a inductive resistance, XC is a capacitive resistance, R is a pure resistance. This is a impedance formula. Now we know that V equal to IZ, V equal IZ, and phase angle phi, then tan phi equal XL minus XC over R, then cos phi equal R over Z. These are the formulas. Next one, what are phasors? The phasor is a rotating vector representing a quantity such as an alternating current or voltage that varies sinusoidally. The phasor representation is a simple way of reducing the complexities of handling single frequency circuit. This is a phasor. A phasor is a quantity that behaves in many regards like a vector. Phasors are used to describe series RLC circuit because the above expression for the impedance can be associated with the Pythagorean theorem for right angles. Here, look at here. This is Z vector. This is R vector. Then this is XL minus XC, angle phi. Similarly, we can say V square equal V R square plus VL minus VC square. That is this triangle. Look at here. This is VR. This is V, and this is VL minus VC. Next one, resonance in AC circuit. In an AC circuit, resonance occurs when the inductive and capacitive reactance are equal in magnitude but opposite in phase at a specific frequencies, known as the resonant frequency. What is resonant frequency? In AC circuit, resonance occurs when the inductive and capacitive reactance are equal in magnitude but opposite in phase at a specific frequency known as the resonant frequency. This results in a purely resistive impedance and the circuit's output is at its maximum. Now, sum here F0 equals 1 by 2 pi root LC. This is a resonant frequency formula. Now, some effects on the resonance in AC circuits. Electrical energy oscillations. Electrical energy oscillates between the capacitor's electric field and the inductor's magnetic field. High voltages. Resonant circuits can generate higher voltages than the voltage fed into them. Next one, ringing. Resonance circuit exhibits ringing. Applications. The resonant circuits are used in radio transmission for both reception and transmission. The sharpness of resonance is affected by damping and amplitude. As damping increases or decreases, the sharpness of resonance increases or decreases. As the amplitude increases, the sharpness of resonance decreases. This is vice versa. Next one, power loss in AC current. Suppose that an AC voltage V is impressed across an impedance of any type. It gives rise to a current I through the impedance, and the phase angle between V and A is phi. The power loss in the impedance, that is power loss in the impedance, the formula is equal VI cos phi. Power loss formula. The formula for power loss in an AC circuit P equal to I squared R. This is from Ohm's law, where I is the current flowing through the circuit and R is the resistance. Power factor. What is power factor? A power factor is a measure of power loss in AC circuit. It is the ratio of the real power consumed by the circuit to the apparent power consumed by the same circuit. The power factor is less than the theoretical maximum of the circuit because a voltage and current being out of phase. Next, impedance. What is impedance? The impedance is the net resistance to the current flow in AC circuit that contains resistance and reactance. Impedance is resistance and reactance together forms an impedance. Minimizing power loss. Power loss can be minimized by increasing the inductance and decreasing the resistance. Increasing inductance and decreasing resistance, then power loss can be minimized. Next one, transformer. A transformer is a device that transfers electric energy from one alternating current circuit to one or more other circuits, either increasing, that is stepping up transformer, or reducing, stepping down the voltages. When here in transformer primary circuit, this is a secondary circuit. If number of turns is more in primary circuits, it is, and secondary circuits number of turns is lesser than primary, then it's called step down. In the step down voltages, step down transformer voltage is reduced in secondary. And vice versa, that is number of turns in primary is lesser than the number of turns in secondary, then it's called step up transformer, and that voltage is increased in secondary. Here and here this side, secondary sides, this voltage is increased. So far we discussed about AC current and their factors, forms and different formulas. They have done. Please subscribe our YouTube channel.